I'm showing my class diagram here again as a reminder of what I'm working towards. So far I've finished the mappable interface with its abstract render method and static method, and I've got the point and line abstract classes. I'll start with the park class that extends point. I'll create a new class park in the dev.lpa package and have that extend the point class. I'll add the field name. Next I'll add a constructor which I'll generate, selecting name, and that gives me a constructor that also has location, the location string there. I want to move location to the last position in the constructor parameters, not the first. You'll see why I'm doing this a little later when we duplicate this class into another one. Finally, I want to override the toString method, so I'll use the override tool to do that. With that, I'll now replace super.toString because I just want to return name and concatenate national park to that. If I had other fields, I could include them here. And that's our first class that will render itself as a point on a map. Now I'll copy and paste that class, calling it river, to create the first line class. I'll have it extend line, not point. In the constructor, instead of passing a single location string, I want to allow multiple location strings using a variable argument and call that locations. I'll change the call to the super constructor, passing locations, not just location. Finally, the toString method will return the name and river concatenated to that in the description. At this point, I've built everything except the generic class and the main class, so I'll do that now. First, the new layer class. The first thing I need to do is make this generic, so I'll add a type parameter, and you might remember from the requirements that this class should only take mappable types. In angle brackets, I'll add T as the type and extends mappable after that. This sets an upper bound, meaning anything that is mappable can use this layer class. It also means we can use methods on mappable without casting. I want to set up a list of mappable elements. I'll make this private because I don't want any direct access to this list. Private list of T layer elements. Next, I'll generate a constructor that includes layer elements. That gives us a constructor that will take a list of elements, but I actually want that argument to be an array. I'll change that list T in angle brackets to just a T square brackets. I want to create the list as an array list in the constructor of type T. This constructor lets the calling code pass an array to create a new layer. Now I want to include a method to add one or more elements. If I use a variable argument, this can be a single method, which I'll call addElements, public void addElements, and then I'll have tvarargs and name that elements. Layer elements.addAll passing list.ofElements. The variable argument uses the T parameter and simply calls addAll, a method on the list interface. This method takes a list of data, not a variable argument, so I can generate a list with the list.ofMethod with variable arguments. Next I want a method called renderLayer. The for loop uses the type parameter. Because I've defined my type as extending mappable, I can call the render method on this type parameter the loop element, as I'm showing here. And that's a generic layer class. For the main method, I'm going to set up 3 parks and 4 rivers with their locations from the tables I showed you on the challenge slides. First the parks, I'll type this out, so bear with me. I'll use var because Java can infer that it's a park array, so var national US parks equals new park array left curly brace. This sets up an array initializer, and I'm going to instantiate a set of new park objects. New park Yellowstone, and I'll pass the coordinates as a string 44.4882 and minus 110.5916. That's our first park, but I want a comma after that because I have more. New park Grand Canyon and its coordinates from the slide followed by a comma. New park Yosemite and its latitude and longitude. Those are the parks. I want to create my park layer next. Layer of park layer equals new layer, angle brackets passing national US parks. Call park layer.render layer. The park layer should only take parks, so I am very specific about the type. It creates a new layer passing the array of parks I just set up. Then it calls render layer on the park layer. Let's run this code to see what it does. You can see the output, the 3 national parks, rendered as points with their latitude and longitude given. I'll now create the river layer. This time I'll start with 2 rivers. var major US rivers equals new river array, then an array initializer. Next new river passing Mississippi, and I'll just type out the coordinates of the points in the line here. We had 3 in the table for this river. Obviously, if we were really mapping out a river, you could have many thousands of points depending on the accuracy needed. A new river Missouri with just 2 points defined. That sets up the array of rivers which I'm calling major US rivers. I only set up 2 here because I want to use the other method I created on layer called addElements. Before I do that, let me create a new river layer. Layer of river, river layer, equals new layer angle brackets passing major US rivers. Now that I have a river layer, I can add more elements, just one or multiples using the addElements method on that layer class, riverlayer.addElements, and I'll pass that new river Colorado with 2 line points. New river Delaware, and its coordinates for the start and end of the line. Finally, I'll call render on this layer. Let's see what that does. You can see the layer printing out information for each type in its list. So our layer generic class never had any knowledge about the point or line classes or the park and river classes, but was able to make use of the mappable class as its type parameter to support a container for these classes. The generic class is another powerful tool in our arsenal to write robust, reusable and extensible code in Java. It does get more complicated, but for the most part what we've talked about so far covers what you'll probably be doing most with generic classes. In an upcoming video I'll dive into a few of the more advanced topics, but first let's revisit a few interfaces we've used previously. I can cover them more fully now because we've gone over both interfaces and generics. I'll see you in that next video.